Welcome to this video on calling APIs in Flutter. After watching this video, you'll be able to use API calls to fetch external data from a server. You'll also analyze how to leverage asynchronous programming in API calls. Finally, you'll explore how to make your first API call through a series of steps. Many people use their phones for weather alerts to plan their daily activities. Application programming interfaces, APIs, bring this data to their phones. APIs work behind the scenes to facilitate communication between software systems, providing your app access to real-time data on a distant server. This access to external data will help you build dynamic mobile applications in Flutter that seamlessly integrate external data. API interactions are typically asynchronous network requests. The app sends a request over the network and waits for a response, which may be unpredictable due to network latency and server processing delays. Handling these blocking operations synchronously forces the app to wait for the API response before continuing, which blocks the main thread and can cause the app to freeze or become unresponsive. Future and async or await keywords can prevent your app from freezing while awaiting the API's request. Let's have a brief look at these keywords. A future is a potential value or error that will be computed soon but isn't available yet. It serves as a placeholder for values in asynchronous operations. The async and await keywords pause code execution until the future value returns. You can follow these steps to make a correct API call. First, identify the web address or endpoint from which you want to fetch the data. Next, use a package called HTTP to communicate with the server holding that data. You can use HTTP GET or HTTP POST based on the nature of your request. Next, you will have to interpret the response from the API, which will be in a JSON format. Follow these steps to parse and interpret the response received from the server. Use JSON decode to transform the JSON string into a Dart object, such as a list or map. Create a Dart model class with properties matching the JSON string structure. Map the model class with the decoded JSON data so you can use them in your app. Finally, update your Flutter UI to display the parsed information. Use the stateful widget and its mutable state to hold API data that can be used later. The setState method notifies the framework that the object's state has changed, triggering a UI rebuild to reflect the new state. Since API calls are asynchronous, errors caused by network issues, invalid responses, or server downtime are highly probable. Implementing error handling measures is essential so your app remains user-friendly and responsive when critical errors occur. Let's look at some common error handling techniques. The first is a try-catch block, which encapsulates your API calls in a try block. The catch block includes logic to handle exceptions and prevent your app from crashing. Next, a timeout can prevent your app from freezing indefinitely. Set a timeout duration that isn't too high to prevent the app from becoming unresponsive. Finally, meaningful messages should be displayed when an error occurs so users can try again later. Let's look at a code that provides an essential structure for dealing with errors during API calls in a Flutter application. The app uses the HTTP package to make API calls. The isLoading variable manages the loading state, while response message shows the results or error message. The fetch data method encapsulates the API call in a try-catch block. It includes a timeout of 5 seconds to avoid freezing. Depending on whether the call was successful, the UI is updated. Let's look at some essential best practices to ensure efficient API interactions. Minimizing the number of API calls can optimize performance. Implement caching to store data locally and improve load time. You can enhance security by using HTTPS to encrypt and transmit sensitive data from your server to external software systems. Use authentication protocols to protect data and data validation techniques to prevent incoming attacks. Use modular code to separate API logic from UI code, improving code maintainability and testability. Finally, implement efficient error handling to prevent crashes and provide timely alerts. Let's now look at some considerations for seamless API interactions. Become familiar with future and async or await keywords to manage API's asynchronous nature. Create try-catch blocks to manage potential errors and provide user feedback. Become familiar with HTTP methods such as GET, POST, DELETE, and PUT. Use Dart convert to parse JSON data into Dart objects. It's essential to map JSON structures with Dart classes for convenient data manipulation. Become familiar with Provider, Riverpod, SetState, or Block to handle state changes for UI. Take note of API rate limits to avoid getting blocked by the server. Implement debouncing requests or caching responses to manage rate limits efficiently. Use additional headers or authorization tokens in your request. Ensure that you securely store sensitive information. In this video, you learned to understand APIs and their role in helping apps access external data. Use precautions to prevent apps from freezing due to the asynchronous nature of API calls. Create your first API by sending a request to the server, parsing the JSON data, and updating the UI. Identify and manage errors using error handling techniques such as try-catch blocks, timeouts, and user messages. Understand best practices and key considerations for API interactions.